Hi guys, let's do binary tree level order traversal. So we're given the root of a binary tree and they want us to return the level order traversal of its nodes values. So from left to right, level by level. So we're given an example here where we have this tree and we would return this array. So basically what's going on here is in this array, so if we just look at the tree from top down, left, right, then we would count the nodes as 3 in the first level, so 3 would be in this first array here. Then in the second level we have 9 and 20, so in this second array we have 9 and 20. And then in the third level we have 15 and 7, so in this last array there's 15 and 7. So it's like up, down first, and then left, right. So level by level, and then left to right. So in example 2, we are given, let's pull up the diagram, we're given a singular node of 1, and so we would just return 1. In example 3, we are given an empty tree, so we return an empty array, or array list, sorry. So since we're going level by level, we know that this is going to have to, we're going to have to use a BFS. So we can basically just traverse through the tree, and for each level we can add all of the nodes into an array list and then add that array list into another array list, which is what we're going to return, because as we can see here, we're returning a list of integers. So let's start with the base case. So if we have an empty tree like in example 3, then we will just return an empty list. So if root is null, return empty array list. Okay, otherwise we are going to do our actual BFS. So we need to create this list that we're going to return in the end. So we're going to say list of integers, and we'll just call it list is new array list. And then we also need to set up our queue for our BFS. So our queue of tree nodes is going to be a new linked list. Okay, and then we're also going to add the root into the queue, because that's how we're going to start. We're going to start the BFS from the root. So queue.add root. Okay, and then while our queue is not empty, then we're going to do our BFS. And so currently our queue has one node if we're looking at example 1, which is 3. So I'm just going to use example 1 as our example here. And our list is currently empty. Okay. And then while our queue is not empty, so we're going to say the nodes in current level is the size of the queue. And we also want to create an empty list, because we're going to store all of the nodes in the current level in this list. This is going to serve as our inner lists here. So see how we have a list for each level, so that's going to be this list. So we're going to say list of integers, and I'll call it level, and we're going to just initialize that. Okay, so now we can loop through all the nodes in our current level. So for I equals 0, I is less than nodes in current level, I plus plus. Okay, then our top node is going to be the node removed from the queue, so that's currently 3, and then this gets removed. And our level is an empty list currently. Okay, so we're gonna add all of the nodes. So we're looping through all of the nodes in our current level, which is only 3 right now. But for every node in our current level, we're gonna add that into our list called level. So we'll say level.add node. So now level will have this node 3 in here. Then we're going to add the next level's nodes into our queue. So if node.left is not null, queue.add node.left, same thing for the right node. Okay, and then, so once we do that, so for the next level, we'll add 9 and 20. So we'll have 9 and 20 in our queue. And now once we have iterated through all of the nodes in the current level, because like these are going to be erased out of the node, like we're removing all of the nodes out of the queue for each level, and so we don't want to, and also we're updating level for every level, right? We're updating this list called level, sorry. So before we erase it, we want to add that into this list. So we're going to, at the end of the for loop, because that's at the end of each level, we will add that list into, like the list called level into our list called list, which is the outer list, if that makes sense. So we're going to add level. So now list will have another list inside of it with this 3. So let's do another level so you can see more what's going on, since this one only had one node. So then for the next level, we have 2 nodes, right? We have 9 and 20 because the size of the queue is 2. Then the top node of the queue is 9, so we remove 9, and that becomes this node. We'll add that to, level is a new array list, sorry, because this is a new start of our for loop. So it's empty, but then we add this node into level, so level now has 9. Then we will add node.left and node.right into the queue of node 9, which they're both null, so we don't add anything. And then the next iteration of this for loop, our next node is going to be 20, so this becomes 20. Then we will add 20 into level, so level is now 9 and 20. And we remove the 20 from the queue because we removed it here. Then we'll add node.left and node.right into our queue for node 20, which is 15 for node.left, so that will get added first. And then 7 will get added. So that's now what our queue looks like. And then now that we're at the end of the for loop, we will add our list called level into list. So then this will also have another list with 9 and 20 in it, like that. Okay, and then our next iteration level will get reset here. So this is empty. Our queue's size is now 2 because we have 15 and 7 in here, as we can see. And our next node will be 15. So 15 gets removed and stored into this variable called node. We'll add 15 into level, so level will have 15. Then node.left is null, node.right is null for 15, so nothing happens there. Then in our next iteration, we have 7, so 7 will get removed off of the queue and stored into this node variable. And then we'll add that into levels, so now we have 15 and 7. Then node.left and node.right are null for 7, so we don't do anything here, and then we exit out of the for loop because that was already 2 nodes. Then we'll add this list into levels, so now this list, which is 15 and 7, will get added here. And then now our queue is empty, so we exit out of this loop. And now that we've done all of that, then we need to just return this list. Because if we take a look over here, we have 3, 9, and 20, and 15 and 7. So that's exactly what we want to return. So we're just going to go ahead and directly return the list at the end of the while loop, just like that. So let's run that. Oops. Node.val, not node, sorry. Concept is still the same though, but I should have noticed that. Okay, so that's that. And then our time complexity. So if we think about this algorithm, we're just doing a BFS on the tree. That's basically all we're doing, right? Because we're just looping through here, visiting every single node and adding every single node into a list. So that is just going to be O of n, where n is the number of nodes in the tree. And if we think about the space complexity, so if we take a look at our data structures here, we have this list and we have this queue. And we also have, well, this list is going inside of this list, so I'll just include it in here. But those are our only 2 data structures. So let's start with the queue, right? So the queue at one point is going to store every single node that's in the tree. And worst case, it could have every single node at one time if they we're all in the same like level, I guess. So, like, or if we only had one node in the tree or something like that, then every single node is going to be stored in the tree technically. So this would be O of n for the queue. If we think about the list of integers, well, this is also just storing every single node, right? Like if we look at this here, the tree has 3, 9, 20, 15, and 7, and this list has 3, 9, 20, 15, and 7. So this list is also just storing every single node value, basically, which is also O of n. It's just like organizing it more, right? In example 2, we only have one node and our list only has one value. So it's directly proportional to the number of nodes we have. And this one is empty and the list that we return is empty. So the list will also store O of n. So our space is also going to be O of n, where n is the number of nodes in the tree. No matter what, like this is always just going to be O of n. So that is it for this problem. Thank you guys for watching, and like and subscribe if you found it helpful. Bye!